Hello everyone, welcome to today's after school club. We are usually do design on Mondays. If you don't know anything about after school club, I can take you to the website here. Let me just transition. There we go. Yeah, you can go to our website, click after school club. Then here you can see all the things we do. We pretty much stream Monday through Thursday. Monday's design, Tuesday is kid coders, Wednesday is, making, inventing with the take and makes, and then a guest speaker on Thursday. And you can also go to our YouTube page or Twitch archive to check out some older stuff. Now, so this is actually part of a 4-week series, but if you haven't seen previous weeks, that's completely okay. Again, we kind of focus more towards design. You might be thinking like, why are you inventing something with Arduino? It kind of focuses on design with making something new here. So a little bit what we did last week, we made paper prototypes or physical prototypes that just give us the idea of what we want. And the main idea we had was to have like an auto translator. Yes, we do have phones with auto translation, but we need something for like libraries where we're not handing a small device in front of people, more of like a big screen that people can go up and talk to, translate together, because not everyone speaks English. There's people who speak sign language. It'd be nice to have a camera or something to translate that, or Spanish, or German, or I don't know, Chinese, Japanese, Cantonese. But we made a little paper prototype. This is it sideways. Try to turn it around. It's very flimsy because, it's not meant to last, but it's like a little keyboard and screen with a little mic on top. This is the library side where they see something that's translated automatically. It's like a double screen, and it just broke right now. And this side is the guest screen. And it broke. I guess I'm done with this prototype now. I got my use out of it. I was just kind of showing what we made. I mean, like, you can do so many things with stuff that you have around your house. Okay. So I'm going to show you what Arduino is and then how to start inventing stuff with Arduino. So I'm going to switch to another camera here. Oh, it broke. I'm going to fix that real quick. See if it fixes it. Nope. There we go. So I have an Arduino right here, and then Raspberry Pi. Raspberry Pi is another type of microcontroller. A microcontroller is a mini computer that can invent to do stuff. So if you've ever heard Raspberry Pi, this is more for like software stuff. Some people actually use these to make magic beers, which funny enough are becoming popular right now with exercising equipment. And this right here is the Arduino. See if I can get the camera to focus this right. We'll be building with this. It's got a bunch of like inputs. Come on, focus camera. You can do it. Nope, doesn't want to focus. But even though it's blurry, it's got a bunch of numbers through here and here for different pins, and it basically tells you what to do. But before we get into this stage, the next thing I should say, these are actually really cheap. They used to be really expensive, but now you can get them like for $40. I mean, if you go for you can totally buy off-brand Arduino stuff for much cheaper, like 20 bucks or 10 bucks. That's what I usually use. I should do it this way, camera. That's what I usually use. But the official Arduino brand stuff is expensive. But again, you can get like an off-brand kit real cheap, like online. Hopefully in stores soon. So I'm going to switch to my computer screen now. Just realized I need to switch off the screen because... No, we don't. No, we can stick here. So let's say you have an idea. We have our idea of making an auto translator that's good for libraries. That isn't a small device, that can spread germs really quickly. And, we have an idea, but how do we transfer that idea to Arduino? Also, if you just joined us today, you can always talk to us on Twitch and on Facebook comments. I'm here, it's here to talk back and forth if you got questions, or if you just want to say hi, I am fine with that too. It looks like my camera above is, there we go, anyway, a little bit. Here we go. Okay, So you have an idea. Now what? So I'm going to look over a few things on here. If you're very curious about Project Invent, this is from Project Invent. You can go to projectinvent.com and learn a little bit more of the design process. I kind of went over it before, but I'm going to look with looks like versus works like. This is a bunch of pen pal for like writing stuff, and it automatically inscribes as digital. So this is talking about like telling people to make what it's going to look like in the end model, and then what it works on the inside. A little exercising. So I'm just going straight to determine inputs and outputs. There's the Arduino right there, but we got to think about inputs and outputs when it comes to inventing, because it makes it a lot easier to figure out what you're putting together. So input is everything you put into a device, output it comes out. So let's say for like human brains and stuff, input is someone else talking to you and you're processing information that's coming to you. Let's see, like another example would be eating food. That's input. That's like more literal, giving you nutritions and stuff. And then there's output, like you responding back to what was said to you is output. So in terms of a computer, a keyboard is output, typing things to a computer, gives information to the computer to process. That is your input, actually. That's your input, type it in there. Another type of input is a mic. I'm talking to it and it's recording my voice. Probably a lot louder now, sorry. But it's, information that's going from, outside into the computer. Now, for output, that would be monitors. There's monitors right here that should send you visuals back at you. Another example is sound. Sound is output coming from ears. You're hearing with your headphones, earbuds, or speaker, goes into your ears. So yeah, input's kind of sensing something, and then your brain's thinking, and then output is acting. Just kind of going through here. This is an example things from Project Invent. But here we go, some sensors. So Arduino has a lot of sensors. These aren't exclusive to Arduino. These are sensors that just exist overall when you use an Arduino or other things. Arduino was invented to make it easier for people to just grab random sensors and use it with Arduino. Now, if you think about your phone, it has like or anything with like a volume button that goes high and low. It usually is actually two buttons. So this thing right here, buttons, like there's one at the top and one at the bottom. You press one, it makes the sound louder. The other one makes the sound quieter. Motion sensors, pressure, temperature, light sensor, like the text light turns on. Sound. So it's a microphone right here, listening for sound, and various other things. There's a fingerprint sensor. I don't have that. And then there's the outputs, things that you want to, some information you give to the machine, you want it to give out something. So that will include Wi-Fi. And one of those things I'm like, that technically is an output. Fans cool things down, a motor spins things. Vibration motors, like when your phone rings and it like shakes a little. Those things, lights, text, sound coming out, all that stuff is output. So you should determine what inputs and outputs we need. See if I can do this here. Where are you? Trying to find, where's the interact button? There it is. Okay. So we have, we need a monitor, a screen. I'm just writing on the screen right here for our thing. So if you're inventing something on your own, you can determine what inputs and outputs you need. So screen is one, keyboard is another. For my input, I should type right input. Keyboard. Actually, these are, let me just, oh, come on. It's like old school erasing. Can I just, there we go. Just kind of fixing that a little. So I'm gonna write it right here. Inputs. We're sticking with inputs. I totally got them mixed up. So that would be keyboard. Again, you can totally interact with me on chat, say hi, hello, ask a question through Facebook or Twitch. So we got keyboard, that's an input. We need a mic, that's an input. Now there's a question about cameras. Are they inputs or outputs? They're actually inputs. So because it's taking data, you know, that what it sees like this, and then output it through the screen. So maybe we need a camera. Do we need sound? So we want to be really accessible. We probably need some type of speaker. Hey, let's figure out the things we need. What else? Like, you totally suggest something for our auto translator. Obviously Arduino's the brain that puts this together. We got a keyboard. Just realized I did it again. Speaker is not an input because we're not giving it information. But okay. Output. Speaker. Screen. That's mostly it. So I'm going to be using this computer for my screen and keyboard temporary, but we could make one. Could probably 3D print one. Maybe find a better one, but we're not going to go that hardcore. But so we need, I'm going to go with input, little smaller inputs like the mic and speaker. We'll try those. Okay, so I'm just going to clear that and exit that. So now I'm going to go back over to top down here. Let me see if I can, there we go. Just trying to get that away. Yeah, that's good for now. Okay, just kind of looking over here. There's one more thing I have to look up and have it ready, and I was just like, oh no, I should have that. Okay, so here's Arduino. Here's my keyboard. And you know, we're gonna grab our sensors here. So I have this whole thing right behind me. Here's a bunch of sensors. It's gonna bring my phone out. So our thing isn't super weird and different. Oh, there is one issue where, what if it's always translating all the time? Maybe we should just push a button for it to start, you know, translating instead of it automatically, you know, listening all the time. And we could also just do a button for the keyboard, but it'd be fun to have a unique button for that. Another thing I want to point out is that we're not going to get through, you know, inventing this whole thing all together today. I'm just teaching you guys how to get started with inventing, because this will take a while. Okay, so I got a button. These are transistors right here. These are like big motor. This is a giant motor right here. Oh, it's got a capacitor. If I could say that right. More motors. More capacitors. Trying to remember what these are. Oh, these are potentiometers. It's like this little thing you can screw it. It like what's it called? I'm blinking here. It can control how much electricity is going through it. It's like a limited thing. Here's a little twist button. But there's all types of sensors. This is not the only sensors I have. There's more. There's some more sensors. Looks like someone got a hold of some of these. Oh, here. Okay, so this is the motion sensor. I'm trying to remember. I believe this is. I'm trying to remember what this is. One of those times where I'm just like, what was it again? So here's a little mic. I'm gonna grab one of these then. Here's some mics. I'm gonna use the buzzer to test, but it's not a real sound. This is a speaker, which is much better than these buzzers, but I'm gonna actually grab one of these buzzers. I need to make sure it's not the popping kind. I think the one at the back isn't the popping kind. There's like different kinds of buzzers. Okay, more potential monitors. There's a bunch of switches. Micro things. This is Bluetooth. You have to hold it up to the screen. Oh, this is a gyroscope right here. This is extender. Here's a little tiny motor. Very, very tiny. Giant capacitors. If someone been through this stuff, we're like missing some things. But, you know, not too bad. Okay, there's another thing I'll show. There's like tons of sensors out there. So many sensors. Okay. And this one. More sensors and more sensors. Actually, I think this is just cords. Mostly just cords. It also has a little step motor. So you want to like make something for exercise. This one. Yeah, it looks like this got mixed up. Yeah, this is the tech kit we have here at DSpace Omaha Library. You can check out when, you know, we let you check out things again. Here's more sensors. Here's little LEDs. LEDs are great for testing if input's coming through. Like if it's working, if it's sending out data. More potential monitors. What is this? Oh, LED screen. So that's like little LEDs that come up. What else? Little clicker numbers right here. Different numbers. This is Sunfounder. Not sure what this one is exactly. No, it can't be a breadboard. There's like a little picture at the top. Here's another screen. This is a digital screen. So I guess we can use this one for a mini one for now. Temperature sensors. This is distance sensor. So basically, if you hold your hand close to it, it like, you know, does something. A little far away doesn't do anything. Depending, you know, you could also do the opposite if you want on that. Just need to remember where that sensor came from. Okay, last set. This is like the big one we have here. Got a flame sensor, 2-color LED, LED that goes through all the colors, and there's a difference between analog and digital. I'm gonna be working mostly digital here. This is a switch. Ooh, mercury. That's not good. Oh yeah, this has mercury in it for something. Better not break that. There's like, yeah, there's quite a few things where I'm like, I've never done anything with this. Temperature, magnet, electric magnet. I'm looking for more interesting ones. A relay. There's small sound and big sound. I find it just very calling. I guess it's for detecting like digital temperature. Metal touch, so I guess it's a metal detector. A tilt switch, so this you kind of like tilt it, you know, turn things on and off. Analog laser emission. It's not a dangerous one, but it's got like this little light bulb in the middle. Button. I need 2-color. Hey, joystick. Here's a joystick, so you can like control things around. And lots of fun. There's so many sensors, so many out there. This is tracking. I'm not sure what kind of tracking. Oh, how do I describe this one? So this is actually like it tracks basically what color is on the ground. These is like not infrared. I'm trying to remember exactly. It's been a bit. But let's say you have a like black line or a green line on the ground or whatever, and you want a robot to follow that line. This sensor makes the robot follow that line. I don't know why I'm holding the other camera. Photocell just detects light. Little photocell. Passive buzzer. Is there anything else in here that could be interesting? Oh, a little thing for knocking? Okay. So I'm going to close out that. Okay. So now I have my Arduino and some little sensors here and output stuff, but how do I connect this to this? I mean, I can like directly just like plug this in here, but I shouldn't do that. So I need a thing called a breadboard. No? Don't tell me. Oh, okay. I was worried the breadboard was missing. So this is a breadboard. It's got a bunch of holes in it. Basically, it's a way to organize your sensors. Technically, there is a positive sign and negative sign in here, but it can go any way. But still have an issue where if they put, something here, there it is. Still not connected. We also have wires. So they're usually called dumper cables. Okay, there's all that. But here's another issue. I kind of need to put a code on this. I'm just grabbing a cord. Here we go. Got a cord. And just plugging it to the computer here. I'm plugging it right here. There we go. Now it's on. It's kind of hard to see, but there's like a, yep, little yellow light right there blinking. Here we go. So while I have that on, it's on load. I'm gonna switch over to my computer screen. Transition. So, oh, it annotates back on. Fixing that. There we go. So, if I'm looking at ways I can change some things. Nope. Okay. So you can download Arduino as software, or you can use the web editor. But that's what I'm doing here. I'm using the web editor. It's just create.arduino.cc. But again, if you have no idea what you're doing, you don't want to like go in here and you're just like, well, how do I know? Just gonna sign in for my work space email. Come on. But again, you're like looking at this and you're like, I don't know what to do here. It's just a bunch of them. But again, like I say, I don't know what to do here. So you can actually look up Arduino projects. Learn some new things. Arduino itself has like a hub for creating stuff. You can literally just steal code, and it's not really stealing code. A lot of programmers have like a bunch of codes. Some of it is copyright. There's some code sets are copyrighted, but you can like look things up and be totally, cool. Things. Wow, is that like a physical keyboard game? Oh, that's cool. Yeah. Yeah, and there's like a little tic-tac-toe Arduino game here. A robot arm for those robot detecting like password captcha things. That's cool. But yeah, you can totally like look up these projects if you have no idea what you're doing but want to try something out, learn something. You'll use these. I want to do Arduino trans language. I should type language. You want to be very specific in Googling things. Language translator. or maybe Arduino. I should start with one language first, actually, before moving on to other languages now I think about it. So how I want this is like you speak into the mic and then it prints it on the screen is what we want. Gotta think about it a little bit more. Speech to text. That's it. That's what the actual thing's called. Speech to text. Yep, and here's a project for it. And it gives you all the materials you need. This one has earphones with a microphone for some strange reason. Use this one. Arduino. Microphone. Got an amp for some strange reason. There's a speaker. Exactly what I'm looking for. That just needs recognition. Speech recognition with Arduino. And it's just got the code straight up right there. But not the stuff. Yeah, sometimes it just takes a bit. Convert speech to text. Convert speech. And I'm just searching through things. Of course, it also comes to the problem where I'd be like, this is much harder than we thought. Hmm. It might be the first few things then. Arduino. I'd also suggest things I should look up also on chat. Where's text-to-speech? Arduino's like, is this weird thing? Okay, circuit diagrams. Oh man. I usually stick to the picture. Potentiometer, include library. Talking. This has a little bit more than I wanted. It's probably because that big thing right there. Oh. So it needs a speaker. I want to do the opposite. Oh, it's literally called Speech to Text Shield? There's literally a sensor for that. Ah. Looks like we might have to order other parts. Okay, I'm just going to go with the simplest way for voice. Simple voice recognition project using C# to Arduino. So yeah, this first earlier one might be a lot better. Okay, so we got this here and this here. I hope it's okay with me using a microphone that's separate here. Should be okay. Someone's like, I made this project 2 years back. If you're new, I highly recommend you follow the 2020 update tutorial. So let's try that. What kind of voice project is this? It's saying, in this project, we will turn on off LEDs using our commands. It is very simple, easy, just a little, I know what do we want. Maybe I'm gonna look up Arduino write text from speech. There's this one that's like 3 simple steps. And with the giant speaker. Ah. No, I want the opposite way. It might be base that sensor I need. How can I do Arduino language interpreter? It's the programming language, of course. Yeah, okay. I want my Arduino to write to a text file. It's weird. I know Raspberry Pi projects that do this. Where audio and sound projects. Of course, a lot of them are going to be musical. Is there another way I can change this? Most popular? Get more music-based ones. Just Arduino language translator. And it's more software. Why don't I just do Arduino voice to text? Again, it's gonna give me that stuff. Can I convert voice to text? Is this a way? No, that's not what I'm looking for. Arduino better speaks recognition than Siri. Getting closer. Oh, here we go. So there's someone's code. I'm just muting it for now. Where's your little microphone? Oh, they use it further as well. So they said hello. It's sending the data to, I guess, that component. there's hello. And then they said, thank you. It's not the best. Here's this advanced project, voice to text conversion. Okay. Voice to text conversion, Arduino. Again. Okay, I'm gonna go back to over at Arduino here. I already know how it works. Over examples. Alton, basics, control sensors, display, paragraph, no, strings. Maybe from libraries. That's a lot of libraries. Might go with a simpler project here so I can show something. This other one requires a little bit more research. So, let's say Arduino display text to screen. A little drawing thing. We do have that type of screen. I might have to look off of that because this is a much simpler project. Arduino, screen, LCD. I think it's LCD screen project. There we go. This should be that simple one. Arduino, LCD screen, wires, resistors. So resistor just, makes things not overload electricity. Okay. So once you gather materials, components section, use the picture in the schematics section. Where's the schematics? And they want you to take this code here. LCD clear. Yep, there's the code. So I'm just going to grab all of this or click copy code and then keep that part open. I'm going to go over to here to upload a sketch via USB port. Make sure the agent is installed on this computer. Let's search for port. This is just the Arduino Uno, which should be more towards the bottom. Okay. Okay. And then examples for Arduino Uno. Then paste all of that there. Pile it for me, making sure it works. It works. And then how do I search for one that's on me? Select the board and port. Oh. I forgot to choose a port. Okay. Might have to do that software, but yeah, here's all that stuff. A lot of it, a lot of people say I know what you're saying. I have like an idea of what some of these things are saying. Void setup is just all the stuff with setups. A loop, it just keeps displaying the text over and over and over and over again. And then there's a string on line 27, hello world. So it's outputting hello world. It's going to show on the screen. So next thing for setup. Here's the setup here. I can always download the image. There it is. So I can view it bigger, and it shows me all the parts that I need to connect to. So you notice that this is lights, but again, when you're first trying things out, just try to first start with a LED to turn off and on for your first project, because you can short things out. It's not, it's just kind of something that can happen here. So that's a long C. I'm just gonna, do I want this all the way in? No, let's go down 4. Okay, I'm gonna switch to my screen now. Top down, there we go. Get this out of the way. I've tilted my board here. There we go. So I'm just plugging this directly right here. Then I have this. Now, I prefer to have it not powered before I run things. So now I got that. And first thing I'm going to do is connect ground and power. So this is all stuff you want to learn more of. Like, learning Invention Arduino is not just a one-day thing. It's a multi-day thing. Again, I just kind of plug this in directly right here. Grabbing some cords, unplugged my Arduino. Here's my other sensors. So I'm gonna grab 5 volt. This is upside down. Oh, yeah. Then trying to find 5 volt. Again, it's really hard to see, but there are labels on here. It's blurry. Come on, focus camera. You can do it. It's a little bit better, but there's 5V for 5 volts. Just gonna plug something in there. And then I'm looking for ground. It's right next to it. It's G and D is usually what ground is. And I'm gonna put the positive side here. So there's like a plus right here. Let me bring it all the way up. Well, now you focus. Oh, come on. Bring it all the way up. That's how it focus, right? Anyways, there's this red line here for positive. And then there's a blue line for negative. So how this works is that anything the same at the shorter line, I don't want to say horizontal vertical because you can literally turn this any way, but the shorter line within this line right here, like this is cut to 2 breadboards technically, so this is one breadboard and this is another. So here's one, so any of these like 5, 6 holes in here is one line, those are connected, but things in the long way from one to the other, the numbered lines, actually the A, B, C, D lines right here going from left to right here are not connected. I'm about to lose light. Yeah, there we go. So how this works is that I got power and ground in here, and I need to connect power and ground to the LCD board right here. It's not connected right now at all. I just have power going into the board. That's it. Just gonna make sure it's plugged in here. There we go. I'm like looking, I'm like, how long has the sides been pink? Okay. And then I'm gonna switch over to computer screen again. So yeah, that's what it's mean. There's red is usually positive, black is ground. More ground, more positive, ground again. These are port cords. And these purple ones are the distinction, and then there's the resistor. See there's a light green around these holes? That's where the connection is. But I was just saying this way, left or right, the long side are not connected together, but the shorter side is. So this right here is a pin, and it's connected to ground up here. So this line right here is connected. And this next one is power. It's connected. It's kind of hard to see, but there's like, this doesn't show, but there's actually, these pins are marked on the front side of our board. I'm gonna back over here. Hopefully I can show it. Yep, there we go. See, it's marked right there. The first one is visual something something. And again, anytime you sign something, you're like, I don't know what this is. You can look it up. Hopefully find this information. Of course, when you can look for complex projects, it's a little bit harder. Just trying to pull out. I'm gonna pull out all these cords here. try to stay color coordinated, but there are some times where I just don't have the chords to do it. There we go. So I'm gonna grab ground right here. Usually I want to connect ground first to be safe. And then I'm going to the first pin right here. Looking for a red chord, so I'm adding power now. It's in the same... Okay, so the power and the negative line actually work the opposite. This line. So anything on this line receives power. Anything on this line receives negative. Just the opposite of the pins on the inside. So I have these two black chords together on the same line. I'm gonna hold that up more. And that's how I'm transferring ground to the main board here. Now I'm grabbing power right here, running it through the second pin. There we go. Okay, looks like we need ground again. And I need to put that on the fifth pin. 1, 2, 3, 4, 5. Yeah, the fifth pin. So 1, 2, 3, 4, 5. RW. Right there. Here we go. Wish I could bring my camera a little bit closer. Here we go. And then now for the rest of the inputs. So I'm just going to grab 2 blue chords here. And then I need to grab my 9. Oh, it's on the other side. I need to grab longer chords. Just gonna say all these other random chords are my pin inputs. So grabbing pin 9. Yeah, when you first start, you gotta match everything exactly, and then later you'll learn what these things mean. This goes to third spot. And then pin 10 goes to the second to last spot. And then I'm now just going to grab a bunch of random long chords. Again, you want to keep things color coordinated, but there are times where you just don't have the chord to do it. So I'm making sure I'm not reusing a red and black chord. Okay, 2 right here goes to one next to the last. Looks like we have like opposites here. And next is 3. 3 goes to the opposite side again. And I have to like grab my cursor and like literally line it up from the thing before. Man, I wish I could show all 3 things right now that's going on here. I need to put, okay, 2 through 5. I need to remember that. I'm on 4. Making sure there's none missing here. Okay, and then the last one for the lower numbers. Making sure I'm not reusing red as I look for a longer chord here. I just need a long chord. That's all I need. Come on. There we go. Okay, so this goes to 5. Right here. So I got 1, 2, 3, 4, and that goes right here. There we go. And then when you go to 11, And then put that on the other side of the ground cord over here. And the last long cord, I'm going to show what I'm looking at again. See, these like go into opposites as they twist over. Now I'm on 12. That goes between 9 and power. Not 9 in power. 9 in ground. There we go. Last thing is I need to grab a resistor. And that was 220 ohms, I believe. Oh, wow. Another way is that you see all these marks right here. It tells you exactly where to line these things up. VSS to ground. So this is VSS right here. Again, I wish it was marked on the board here, but this is VSS and it's telling me it's to ground right here. And I'm like, that's nice. Scrolling up, making sure it's 220 ohms, right? 220. I don't know how to add, like do the math for resistance. So I just usually follow the guide and hope. Or find an online calculator for me. Because I'm like, I do this for recreation and not, in a professional setting. Okay, this is a resistor. It restricts power going through. And let's see, I need to put that on ground and on the last pin, just K. K to ground. There we go. And now I can plug in this back into my computer. There we go. Wonder if this board's broken. Now I'm looking at it. Probably why I wasn't showing up earlier. Okay, just gonna unplug this temporarily. Uh-oh. Okay, good. Plug this in. I'm gonna go back to this one. Hold the reset button down for a bit. There we go. Hopefully that worked. Okay, now back to my screen. Okay, so now I'm gonna go over to Arduino editor. It's all compiled. It's got all the numbers here. Now let's see if it detects Arduino now. It said I needed to run agent. I can also just download the sketch. I'm gonna do that. I'm just gonna download the sketch. That is an issue. I'm not seeing it come up as I have it plugged in. Does that show up? That is not showing up on my computer. Okay. I'm gonna do that thing where maybe I should do this instead. Download Arduino. Hopefully it doesn't take too long for me to install it. Hopefully it's really quick here. There we go, opening. Yes. And then, where is it? Copy code again. And green, X, install. Probably unplug this here. Why did it get stuck every time I plug it in? You can also, if you don't want to work with the online editor, you can just download the internet editor. Kind of about 5 more minutes here. Let's hope I didn't unplug anything. Plug anything wrong. But you could do it. Just the last bit. But it's just the last bit. Did it do the thing where it lied to me, where it's like, oh, I'm fast? Nope, not for the last few seconds. Come on. Close. And then, is it gonna open? There we go. Allow access. Hopefully it's okay. Okay, so this thing's a little weird. You always have to like make sure it's working for the board you want. Now I have that. Plug this in. Install that. Port. There it is. Compiled. The little check mark on the top screen. I'm just gonna save it to desktop for now because I'm gonna delete it. Compiling, compiling. You can't see right there. So it's done. Load. Uploading. Done uploading, and there we go. I'm going to switch my screen to the other view now. Here we go. It's kind of hard to see. Probably have to adjust something here. There it is. It just flashed hello world as it goes through. So the next step from here, oh, there it is, hello world on the screen. The next step from here was to be obviously, get text, get a microphone in, and get that, whatever you say in there to display on the screen right here. That'll be the next step. But yeah, thank you very much for watching this today, learning with us how to get this working. Join us next Monday for getting into learning how to rapid design with game jams. Tomorrow is learning with coding. So thank you very much for watching and have a good afternoon.